This is problem number 8 on the sample test problems for test number 1. The radioactive isotope cesium-137 has a half-life of 30.07 years. Assume that a sample presently consists of 10 milligrams of cesium-137. A, write a formula for the amount of cesium-137 remaining T years from now. Okay, so this is a radioactive decay, so we're going to use either PERT or the other formula, the A times B to the T. So we'll fill in what we know. We know that initially there's 10 milligrams, that's A. We don't know B. We do know that there's a half-life of 30.07 years. So if I wait 30.07 years, I will end up with half of whatever I started with. And I started with 10. So after 30 years, I will end up with 5. This is the equation we can use to find B. So divide by 10. It might feel like logs are the right thing to do, but that's not correct. What you want to do is solve this for B by raising both sides to the 1 over 30.07. So that means that B is 1/2 raised to the 1 over 30.07. We'll go ahead and get the estimate for this on the calculator. So we're doing 1/2 raised to the 1 over 30.07. And B is that. B is a number smaller than 1 because it's radioactive decay, so that makes sense. I'm going to write 0.977. I'm going to store this as B, so we hit the store button, and then the alpha button, and then the B is right there, so that I can get the most accurate answer on possible, but we'll just call it 0.977. So then our formula is, from the beginning, f of t equals, A is still 10, B we've just found is 0.977, and that's raised to the t. Part B, how long will it take for only 1 milligram of cesium-137 to remain? So we're going to use the formula we just put in the box, but the 1 milligram has to go somewhere. It goes on the left-hand side. That's how much stuff we have. We want it to be equal to 1 milligram. So divide both sides by 10. And here's where we have to take the log of both sides. I'll use ln, you can use common log. Ln of 1/10 equals t comes down in the front, ln of 0.977. And then finally divide both sides by ln of 0.977 to get t is ln of 1/10. Divide by ln of 0.977. So we're going to get a decimal here. Again, we'll go to the calculator. So we can do ln of 1/10 divided by ln of 0.977. And it looks like it takes about 98.95 years. But that 0.977 that we typed in was an approximation. And we'd be better served by using all the digits the calculator has and not our rounded version. So I'm going to type the same thing, second entry, but instead of typing 0.977, I'm going to delete that, and I'm going to put B, which is what I called that 0.977. So we do alpha, there's the B, and we hit enter, and that's the most accurate answer I can give. And I would argue that the rounding that we did up above is kind of too much. We're off by almost a year in terms of the right answer. So 99.89 is the number of years here. Part C, find the effective annual percent decay rate and the continuous annual percent decay rate. Okay, one of these questions is easy and the other one requires work. The easy one is the effective one. We know that the base in the formula that we use is always 1 plus the rate. And so in our case, we have 0.977 is 1 plus the rate. So if we subtract 1 from both sides, we get our value of r. So it should be 0.977 subtract 1. Again, I like to use the most accurate answer I can get from the calculator. So I'm going to type in b minus 1, alpha b subtract 1. So that right there is the annual percent decay rate, negative 0.228, we'll say. Negative 0.0228. Whether or not to include the negative, I don't know. It's kind of redundant. If we say decay rate, probably we want to say it's decaying at a rate of 0.0228. But either way, it's okay. Annual percent decay rate in terms of continuous. So if we wanted to do this, then what we're after is the number that goes on top of the E, because we're talking continuous interest here. And so there's this nifty little relationship between the B and the E, and the nifty relationship was this. That whatever the base is, it's equal to e to the k, where k is the continuous decay rate. So we found the B already. It's the same 0.977 we've been talking about, and that's supposed to equal e to the k. Take ln on both sides. Ln of the right-hand side is just k. So the continuous rate is ln of 0.977. So we'll type that onto the calculator. But again, not going to type in 0.977. It's really ln of b that we're after. So we do ln alpha b, and that's our continuous decay rate, about 0.023. Again, the negative may be redundant.